right, good morning. How's everyone doing? All right, I know Deshaun's doing good. Ready for day 2? I just want to let everybody know on the live stream, if you're joining us on the live stream, on the right side, there's a button to join in the discussion. That will take you over to the Discord channel. We can keep the conversation going here. If you want to get some questions in there, we'll see if we can answer those as well. But first up, Rob Winch from the Spring Security team. Looking forward to seeing what's new in Spring Security 6.4. With that, I'll let you take it away.
Thanks, Dan. Thank you, everyone. Welcome to Let's Explore Spring Security 6.4. My name is Rob Winch, and I'm the project lead for Spring Security. If you haven't done so already, please go ahead and scan the QR code or use the bit.ly to access the slides and code. Before we get too far, who's here for the code? Okay, quite a show. Who's here for the slides? Okay, sorry. There's only 2 slides, but I think you'll like these slides. This is one, and we have one more. But we have a lot of good code to show. But today we're going to be really focused on authorization, the authorization features in Spring Security 6.3 and 6.4. And tomorrow I'll be joined by Josh Long, or more likely I will join Josh Long for passkeys, goodbye passwords, and hello security. And we're going to be focused on some of the new authentication features that'll be found in Spring Security 6.4. So bear with me. Today is more of authorization focus, and tomorrow will be more of an authentication focus. With that said, I just kind of jumped into some terms here. And if you're new to security, you might be thinking, well, what is authentication and what is authorization? Authentication is the who. Who's trying to access a particular resource? And authorization is, given I know who is trying to access a resource, are they allowed to do so? And in Spring Security, there's a number of ways to do that, but we're going to really focus on method security, which has been around for quite some time. Method security allows you to separate your authorization logic from your domain logic. And that's really important. And like I said, it's been around for some time, but we've added some real exciting new features. And I'll also show some kind of hidden features that a lot of people are not aware of, and kind of talk about some best practices with the method security. So with that said, we're going to be done with the slides, and we're going to start on a demo application. We're going to create a new application, and it's going to be a banking application, but I'm going to name it Spring Security 6.4 just to align with the name of the talk. And you can guess that one of my dependencies is going to be security. And the other one we're going to do is web. And once we create that, this is going to be a banking application, and it's going to have a very simple domain model, which will allow us to focus on our security rather than the complexities of our domain model. So we'll go ahead and create a new bank account object. So actually, let's make sure everyone can see that. Everyone see that in the back okay? Looks like, okay, cool. So we'll go ahead and create a new bank account object. And the bank account object is going to have an ID. It's going to have an owner. And the owner is going to be whoever's bank account this is. And that's going to be the basis for a lot of our authorization logic. The owner will align with the username of the currently logged in user. Then we're going to add an account number and a balance. And we'll need to create a constructor for that, and then we'll also create some getters. All right, we have our simple domain object, but now we want to create a bank account service. And our bank account service is going to be very simple as well. We're going to just have a bank account method, find by ID, and we're going to hard code this because the domain logic isn't really that important. The owner is always going to be Rob, and then we're going to have an account number of 123543 for the balance. I don't have a lot of money. I'm open source. But what we're going to do is we're also going to add one more method, and it's going to be very similar. It's going to be used to describe some of the nuances in how method security works under different circumstances. And so we're going to start off by adding some tests, because like any good developer, we like to have tests, and we can see how we can test these things as well, and we're going to do it first. So We'll start off by creating a bank account service, and we could use the built-in Spring Security support, but we're trying to see what's happening underneath the covers, not just with the test support, but with method security. So we're going to do everything manually first and see how Spring Security can clean that up. But the manual approach will show you what's happening behind the scenes within Spring Security so you can understand how everything fits together. All right, so first we'll create a login method. And to do that, you need an authentication. And a lot of times in testing, you're going to use, as you might have guessed, the testing authentication token. And then let's do that so you can see. And then we'll also need to set that on the security context holder. If you are trying to do any sort of custom authentication, all you need to do is do your domain logic and set it on the security context holder, and Spring Security will treat that like the authenticated user. After that, we're going to do a cleanup. And this is important because we want to make sure that our cleanup is happening after every method, whether it succeeds or fails. Now we're going to add some tests. Find by ID when granted. And for that to work, we said that the account always belonged to Rob, so we'll log in as Rob. And then we'll say this.accounts.findByID. We're going to do the same thing for the getByID method. And we need to do some failures too. So we'll go ahead and copy this again, and then we'll add, scroll up so you can all see. We need to do it when it's denied. So when it's denied, we'll do it as Josh. So Josh Long is going to try to access my account. We don't want that to happen. And to make sure our tests are appropriate, we'll do authorization denied exception. And then Josh also shouldn't be able to access the getByID method, so we'll do that as well. Now, when we run these tests, you can expect that 2 of them are going to pass and 2 of them are going to fail. The denied ones haven't been implemented yet, so we won't be surprised when that happens. So we'll run our tests, and 2 of them failed just as we expected. And again, that's because we haven't implemented it. So we're going to start by implementing it in our actual class and see how it works. So we'll start by extracting a variable here. And as we saw earlier, the security context holder contains the current authentication. So if we're trying to do security manually, we can get the authentication from the security context holder. So an authentication is an interface and it extends principal. So we'll just call it a principal type because that's all we need on this. And if the principal.getName is not equal to our account.getOwner, then we're going to throw a new authorization denied exception. And we'll rerun our tests. And at this point, we expect our tests to pass. And now you can see how we manually set everything up. But there's some things that we don't really like about this. First of all, our tests are being done manually. There's a lot of work to log the user in and clear it out. And also what we don't like is we're mixing our domain logic with the bank account service impl and the authorization. So how can we make this a little better? Well, we could use Spring Security, but we're gonna see how Spring Security does that by creating a proxy object manually. Okay? And to do that, all we need to do is create a class called bank account service proxy. And this is what Spring Security is doing underneath the covers. There's not really anything surprising here. So the bank account service proxy is an instance of the bank account service impl. It's a class-based proxy because it is an instance of that class. And then we need to override the findByID method, and we'll extract a variable just like we did earlier. And in here, instead of doing our authorization logic in there, we're going to take that logic and put it in here. Okay? So this is all Spring Security is doing, except I can generate this proxy automatically using cglib for a class-based proxy. Now, if I run my tests again, you might guess that they're going to fail because the security is no longer in the impl. So all I have to do to fix that is we go up to here and change our instance to the proxy, and we run it. And all our tests pass, just as we expected. Now, one thing that I really want to kind of point out here is the getById method for the failure. And the reason for this is it's going to kind of change how this behaves depending on how we're doing the proxies. You noticed it was very obvious that it did that check earlier, but now it's going to start to get a little more complicated. So get accounts, getById, it goes into, it looks like bank account service simple, but remember it's the proxy instance. And the proxy, so it goes into here, proxy does not override getById, and then the findById is overridden. So this is going into our proxy, which has authorization. So that's why we're still getting that authorization denied, okay? A little hard to follow, but the proxy overrides that method, and it's using that overridden method in the class-based proxy. The other thing that we'll notice in our tests is we're able to refer to the proxy as an instance of bank account service simple. It's a class-based proxy, so you can refer to it as a class, okay? So what is a, we've seen that, but like, why would I use an interface-based proxy? Well, what if I had something like this? In our proxy, we can't extend it anymore. Why is that? Well, it's final. And it's obvious when I'm creating it manually, but Spring Security will have the same limitation. It can't extend the final class because it's final. So even though it's automatically generating it, it's not going to be able to do that. So what can I do instead if I did have a final class? Well, what we can do is we can extract out an interface. And we can do that. Click all the confirmations. And now that we have a bank account service interface in the proxy, instead of extending, we can implement. And it has to implement the interface, not the impl, of course. And it's no longer got the superclass because we're composing now, so we have to add something to compose it with. We'll add a delegate. Oh, I'm surprised IntelliJ wants to add a main method instead of a constructor. Ah, thank you. Thank you. There we go. Thank you, that helped. All right, so then we'll go add a delegate. And now the other thing that we notice is our super is not here. We already saw that, so now we're going to say delegate, okay? And our test is not going to compile because the proxy now needs something that's not extending, it's composing. So what is it composing with? It's delegating to the impl. Now the other thing you'll notice is if this is an impl, it fails, right? Because the proxy is an instance of the interface, not the class. Okay? So it has to be an instance of the interface. Now when we run these tests, are all of them going to pass? Everyone? Anyone? All right, let's see what happens. So we'll run our tests, and the getById fails. And the reason is because we're using composition instead of extending. So when we get into here, getById is going to our interface, and remember this is a proxy instance, so it goes into the proxy, and then the proxy goes to the delegate. The delegate is the impl. So we go into the impl, and now this findById is no longer overridden because remember we're not extending the class, it's composed. So this findById goes directly here, and it skips over the authorization logic in the proxy object. So interface class-based proxies behave slightly different and can confuse people at times. So how do we solve that? Well, it's pretty easy. We can do the same thing that we saw earlier. But the takeaway here is if you're calling a method that's secured, be careful because it might not actually get secured if it's done with an interface-based proxy. So I'll run my tests, and now they all succeed. Does that make sense? At least a little bit? All right, excellent. So we've seen how we can do our interface-based proxies and the class-based proxies and seeing kind of how those differ. But one of the things I'd like to do is like make things a little easier. We've done everything manually thus far. Let's see how we can clean up our tests and use some of the built-in features of Spring Security to make our tests easier to read and align with some best practices. Okay? So we'll go ahead and open up our tests. And one of the things that we'll notice here is that we have this manual login and manual cleanup, and that's not ideal. So what we're going to do is we're going to activate the Spring Security test support by adding Spring Boot tests, and we're going to start with adding with mock user Rob. And this is all we're going to need to do in order to log in as Rob and clean up the context afterwards. And we'll do the same thing for Josh, except of course we need to change the username to Josh. And we'll do the same thing down here. And now if I rerun my tests, you'll see that they pass and I didn't have to do all that stuff manually. Okay, nothing surprising here. But one of the things you'll notice is I'm duplicating this string, Rob, Rob, Josh, Josh. That's not really ideal. A lot of times when you're doing development, you might have like requirements that say you have different personas in those requirements. You might have, for example, a Rob persona. So we'll add the annotation. And for annotations, we always need to have them show up at runtime so we can see them. And then we can just take this annotation and add it to here. And then we also need a Josh persona. So we'll add Josh on here as well. And we need to change the username to Josh. And we're going to just go ahead and preemptively add an accountant persona. And you saw that I was changing the usernames, but you can change other attributes of the user that you're logging in as. So we'll do that. Now these users don't exist. That's why it's called with mock. So they don't have to exist in your LDAP or your database or anything like that. Spring Security just creates them like we did in our login method, new authentication object setting on the security context holder. Doesn't care if they exist or not. So now we'll go back to our test and we'll clean this up. We'll say with mock Rob, with mock Rob. Down here, we'll do with mock Josh and with mock Josh. And now if I rerun my tests, I don't have to remember those personas. They're kind of first-class citizens, and I don't have to remember those strings and get it typos and stuff like that. And if I need to change something about those personas, I can do it in a single location rather than throughout my entire code base. And the other thing that you should notice is we're really trying to centralize our dependencies on Spring Security. With mock Rob, with mock Josh, those are my annotations that I control. So if I need to get rid of Spring Security, I can just remove the annotation on top here, not throughout my entire code base, and add a new annotation processor to set up the user however my new system works. Does that make sense? Isolating things, keeping it different from our business and testing logic. Sound good? Excellent. So the next thing that I'd like to show is how we can clean up our authorization logic. We're creating the proxies manually, but we don't want to have to do that. We want some support for that. But it was good to see how Spring Security is doing that automatically for us. So let's see how we can use Spring Security support to add authorization logic. So what we're going to do is we're going to do a post-authorize annotation. There's a pre and a post-authorize. And post means after. After the method is invoked, I want to do some authorization logic. And that's nice because I need to refer to the bank account object. Remember we did super and assigned it to the variable, and then we had access to it and we did some logic? Well, return object is a keyword for this bank account object. And if you remember, the bank account object has an owner on it. So what we can do now is we can say return object or the bank account owner. And then we're going to also, I did this in this order on purpose. If you're not familiar with spell expressions, and many other languages have this is like a null safe operator. It makes sure I don't get a null pointer. You can look that up if you're confused, but just know that that prevents a null pointer exception. And then the authentication name. Remember, we got the authentication from the security context holder, got the name and soft they are equal. So if this returns true, they'll be allowed to access that method. And we're going to do the same thing down here. Now, there's nothing actually looking at these annotations at this point. So how do we do that? Well, we could use Spring Security to do everything using enable method security, but let's take a peek under the covers of how enable method security actually works. Okay? So we have a first-class citizen in Spring Security called authorization proxy factory, and that factory We can create an instance of it. And now what we're going to do is, remember we manually created authorization logic in that proxy. We're no longer going to use that. Now we're using Spring Security to automatically create that logic based upon the annotation that we added. But we're manually creating the proxy part. We'll make that automatic later, but this is how enable method security does all that for us. Okay, so now if I rerun my tests, they're all green, okay? But again, this is how that's working behind the scenes. Okay, so we've done some pretty cool stuff, but we still have some duplicated logic, which I'm not really exactly thrilled about. If I go back to my bank account service, I have this duplicated string, and Spring Security's annotation is on here. So much like we did with the testing support, we can also create our own, we can create our own annotation. So we'll say post read bank account. And we'll add that annotation, and then we need to say retention runtime. Now if we go back to here, we can add post read bank account. And again, we've removed the dependency throughout our code base. It's all isolated. So if we needed to remove Spring Security, we have that annotation, and that annotation can be processed using something other than Spring Security, and the only dependency is on that annotation. And if we rerun our tests, then they should all pass again. And they do. Okay, so we've seen how we can reduce the duplication and isolate Spring Security, but I'd like to come up with some new requirements to make this a little bit more interesting. How about we add a new test that allows an accountant to access the bank account, because maybe the accountant needs to do taxes or balance a checkbook for someone. So let's go ahead and add that. We'll add a test, and like a true test-driven developer, this is going to fail initially. So we'll do accountant, and we'll run our tests, and this should fail because we haven't granted access to the accountant yet, okay? So how do we do that? Well, we can go into our annotation, and we can just say, or has role. And this is another keyword, account has role. And you might be wondering also, where do I find these keywords? How did you know return object? How did you know authentication? How do you know has role? Well, if you click on here, it actually takes you to the Spring Security, the security expression root. And it has those objects on there. So if you look here, get authentication, that's how it accessed that authentication object. It has a has role method. This is all in the reference documentation too, but it's also nice to know that it's at your fingertips within the IDE as well. Okay, so now that we've done that, we should be able to rerun our tests, and it passes, okay? So that was easy. And the other thing that I want to point out that's really nice about that is I modified a single location. But if I do the same thing for get by ID, if I do the same test for get by ID, because I had that annotation, I only needed to edit it in a single spot. Okay? Does that make sense? So that's another great thing about these annotations that I own and control. I don't have to duplicate the string, update the string everywhere as also. All right, so those are some pretty cool features, but I want to go into something that's something else that's pretty cool. What if the accountant could access my balance and stuff like that, but the accountant was not allowed to get account number? I don't want the accountant to be able to access my account number, because if they did, then they could transfer funds out of my account. All they really need is to be able to see the balance, okay? And so what I'd like to do is I'd say, assert that there's an exception of type authorization denied exception. And that happens when I do account.get account number, all right? And as you can guess, this is probably going to fail. And it does. So how can I enable that? Well, I can use a pre-authorized annotation. And the pre-authorized annotation, I could say this. This refers to the bank account object. And then I can say owner, remember there's an owner on it, equals authentication.name. All right, and then, oops, that's not gonna work because this object's not being proxied. Because if we look inside bank account service impl, remember we're just creating that object. It's not being proxied. What we could do is we could do the same thing we did earlier with the authorization proxy factory if we wanted to, but we're not going to do that because that's mixing our security logic with our domain logic. So how can we improve that? Well, there's a new annotation in Spring Security that allows me to handle that without doing anything special. I could just say authorize return object. And now, because this is the return object, Spring Security is using that factory automatically in the proxy on the bank account service to make bank account a proxy in and of itself. So now if I rerun this, it's passing. So not only can a Spring Bean have method security, but objects returned from the Spring Bean can also have method security. Okay? Awesome. So we've been able to see some cool features, but we're still creating that using this proxy factory directly in our tests. So how can we clean that up a little bit? Well, we're just going to have to make this a Spring Bean and enable method security. So this is how you've probably seen method security work in the past. So we'll just enable method security. And in here, we'll also need to, oops, not this, sorry. We need to do service here. And then in our application, we'll enable method security. So now if I rerun, we'll run all the tests now since we made a lot of changes. Make sure everything's still working. All right, and it is. So there's still some things that I think leave to be desired about this solution. And one of them is, if you look at my test over here, if you look at this test, I'm trying to invoke the get account number, and I'm catching an authorization denied exception. If I'm doing that everywhere in my code base, Spring Security's authorization denied exception is everywhere in my code base, and that's not good, right? We don't want that. But how can we make this work? Well, a lot of times you might handle that by doing something like returning a mask. So let's say we want to assert that. We'll assert that this is going to return is equal to, okay? So obviously that's going to fail, but let's go ahead and create one more. And if it's Rob, we want it to be the original value. So remember our original value was 1, 2, 3, and then we need to do this when Rob. So what am I doing here? I'm saying that if I'm invoking the account number and I'm not allowed to do it, I want it to be masked. If I'm invoking it and I'm allowed to see it, then I don't want it to be masked. I just want it to be the original value, okay? So we'll go ahead and run the tests again, and we'll expect that one of them fails because we haven't added that logic, and it does fail, and it's because we're getting access denied. So how can we clean this up a little bit so that we're not trying to do try catch everywhere within our code base, and yet the accountant can't access the account number? So what we can do is we can add a new class called mask authorization denied handler. And it's going to implement, you guessed it, authorization method authorization denied handler. And we're going to add a new method, and it's called handle. So a handle takes in a couple arguments. It allows us access to the original method invocation, also has an authorization result. We're not going to use any of those in there, but what we can do is we can just say 1, 2, 3, 4 stars. That's what our test is expecting, right? And then on here, we can say that we want it to be a Spring Bean. Now that it's a Spring Bean, we can go back to our bank account object. And on here, we can say, oops, on here we can say handle authorized denied. This is another new feature, and we're going to specify that class that we just defined. So now what's going to happen is Spring Security's aspect or proxy object is going to evaluate this expression. If it's true, everything just happens as you expected. If it's false, access denied. But because we've added this handler, now it's not going to throw the exception right away. It's going to invoke this method. And you could actually, if you wanted to, you could actually throw another access denied exception that's custom here. You could customize how that exception is being thrown, or you can customize what's being returned. You can do lots of things with that. But for this use case, we're just going to return the asterisks. All right? So now that we've done that, we'll go ahead and run our tests again. And it should just work. It does. All right? So we've seen how we can clean up Spring Security to reduce our redundancies. We've seen how we can add method security to objects that are not Spring Beans. And we've seen how we can globally, or not globally, but transparently handle the authorization denied exceptions. But I think there's some more things that we could do to, that you might see in a real world application. So let's open up our bank account service. We're going to add a couple more methods to here. We're going to add them as default methods because we don't really care about the implementation. We're just trying to do security here. And that way we can just only update the service instead of our implementations. So we'll say void, and we'll call it save. And it's going to save a bank account. And the variable is to save. All right? We're going to do the same thing here. And this one is going to be called update. And the variable is called to update. Now, I'd like to go ahead and go back to our tests and create a couple tests for these. So we'll start by adding a test for update when it's Rob. And we're going to just hard code this one in our test too because it's just a test. Call it 1, and then the owner is always Rob, and then the account number is 123543. Okay, so it's just some mock data for our testing. And then we're going to say update account. All right, and then we're going to do the same thing for a denied case. We're missing some use cases because we're not doing the save, but that's okay because this is a demo. I don't have to test everything. Update when denied. And when it's denied, we're expecting this to have, an authorization denied exception. All right, so we'll run our tests again. And one of them is failing, and that's because we haven't added the authorization logic, right? All right, so we'll go ahead and add that. And I want to show a couple things here. So this is a pre-authorized because we're going to do it before the method is invoked. And I'm going to be able to refer to the variable that's being passed in, to save. And to do that, I first say number, hash, whatever you want to call it. That says that it's a variable, and the name of that variable is to save. Okay? We established earlier bank account has an owner object. So we'll see if the owner of that is equal to the authentication name. We'll do the same thing here, except in this case, it's called to update. So it's a little different, very intentionally. We could align these variables, but it defeats the purpose of the demo, which we'll see in just a second. So we'll run the tests, and they should just all pass. But what if I want to get rid of this redundancy? It's very similar, but it's not exactly the same. Earlier we saw when it was the exact match, but what if we want it to be, almost an exact match? So what I could do is I could say, okay, we'll do pre-write bank account. We'll go to the annotation. We always need it retention runtime, so it gets picked up at runtime. And then we'll add this. And we'll go here and we'll say pre-write bank account. And we'll duplicate that. Now, we're expecting that this is going to fail because remember, our to save was not being used on the one we copied over as the to update. So we'll run those tests. And we get a failure. we kind of expected that, right? So how can I use this? Because it varies slightly. Well, Spring Security actually has a new thing called templates in the expressions. And I can specify a template. I don't want to have a default value. So what I can do is, if I wanted to name this value 2, I could do value 2. These just have to align, okay? But we're going to do value because it's neater in an annotation. We don't have to do the attribute name of the annotation. So now in my tests, in the service, we need to specify that in. So to save, to update. And now what's happening is this value, to save, is put in the value, and then Spring Security, before it evaluates the expression, replaces to save or to update with that value, and then evaluates it. And you can do all sorts of stuff with this. This is just one example of how you might use those expressions. And now we're going to run it, and you might expect everything to work, but you'd be wrong. And the reason for that is we added this in a minor release. And you can imagine that users might already have curly braces, something that looks like this in their expression. Maybe they're doing like a string, single quote, curly brace value, and it has some special meaning in their domain model or whatever. So we don't want to break anyone. So what you have to do in order to activate this in Spring until Spring Security 7 comes out, is you have to create a bean of pre-post template defaults. And we'll use this for customizing that behavior in the future, but just the presence of that bean actually activates that support. So if you want to activate it, you have to expose a bean of that type. Otherwise, it's not going to be activated because we don't want to break anyone. Okay? So now I run those tests, and you can see they all pass. Okay? Excellent. So we've seen how this can be used in all our tests, but it's one thing to be working in tests, but like a true developer, I want to see it in a real application. Well, real is a little bit fuzzy here because this is definitely a demo application, but let's see it in a web application and see if there's anything that we need to know that's special about this. And spoiler alert, I'm showing it, so there is something we need to know. So let's start by going to our bank account application. And remember earlier I said that those users don't have to exist, our personas that we talked about. Well, for running the application, we do need those users to exist. So we need to create a user detail service. And the user detail service is how we log in. And we're going to create a user details for Rob. In fact, we'll do it for each of our personas. And we'll do it for Rob. We'll do password of password. I know it's really bad that as the project lead of Spring Security, my password is password, but shh, don't tell anyone. Oh, we're live streaming? Oh, okay. Well, secret's out. User build. All right. And you might see that it's highlighted with default user default password encoder. And that's to give you kind of a warning. The password encoder is a good idea to use, but the problem is that this password is still existing in plain text in the source code, so it's not really secure. You should really hash that password outside of your code before you compile it. But it really makes it difficult to use and test and be a developer. So we leave that around for people, but it's really just a warning. But the nice thing is if someone got a dump of the memory stack here, it would be using bcrypt. And I'm not going to talk much about bcrypt, but it's a safe way to store passwords. We'll talk more about that tomorrow if you attend tomorrow's session. So in-memory user details manager. And now we also need to create a new controller. So in here, we'll create a REST controller, and we need to create a bank account service. And I don't know why I just accepted that, because I really like it to say accounts. And we'll do get mapping, accounts, ID, bank account. Find by ID. All right, so now we have the bank account controller. And what we're going to do is we're going to start up our application. And we're going to see what works and what doesn't work. And we're going to access it through just using HTTP. So I'll access it. It tells me I need to authenticate. Nothing surprising there. Auth Josh. And it tells me that it's forbidden. Nothing surprising there, because remember, Josh can't access my bank account. All right, now we're going to do it as Rob. And you might think, oh, this is going to work. And you think wrong, 500. Why is that happening? I'm going to spare you the details, but this long stack trace says Jackson had a problem. And you might say, well, why is Jackson having a problem? That's kind of weird. Well, let's think about this just for a second. We're returning a bank account object. And we talked about how Spring Security adds the security using aspects or proxy objects. And those proxy objects are either interfaced or class-based proxies. Well, we said authorize return object. So there's security on that object somehow. What is Spring Security doing? It's creating a proxy of bank account. And that proxy of bank account is a class-based proxy because there's no interface. And it has additional methods on it. Those additional methods, Jackson has no idea how to serialize those. And so what we can do is we can say JSON serialize as bank account. And by doing that, the bank account object methods are the only thing used for serialization. It ignores the extra ones on the proxy object. And we're looking at making this easier in the future, but for now, you're going to have to do something like this to tell Jackson how to serialize things. And so if I restart my application now, and I run it, you can see it works. Okay. Now, the other thing I really think is fun is seeing this in action. Remember how we had the exception handling for the access denied? So our accountant should be able to see everything except for the account number, and the account number should be masked. So we'll go ahead and run that, and it's forbidden, which means I misspelled accountant, most likely. So we'll check our here. I'm going to spare myself the details and go to our bank account. Somewhere I misspelled it. And we'll try it again. There we go. When in doubt, I misspelled something. So we have a mask. We're able to access that. And one other thing I want to show you, we're going to be pressed for time for questions, but we can do that afterwards. I'd really like to show you another thing that's kind of nice about Spring Security that not a lot of people really realize. This expression is kind of difficult, right? If you look at this expression, it's like, whoa, where's that coming from? Let's see how we can clean that up too. Instead of doing that, we can delegate our logic to a Spring Bean. So we'll just create this as a component. And the method signature will return a Boolean, just like our spell expression did earlier. And we'll call it check. It doesn't matter what we call it. And then authentication. So it takes the authentication that we've been seeing. And then we'll also take the bank account. And then in here, we're going to say if the authentication.getName equals the account, the account.getOwner, then we're going to return true. Otherwise, we're going to return, and I'm going to cheat a little bit here. So we're going to say has role, and so this is a built-in Spring Security Authorization Manager. So we're going to use that just to make it easier. But you could implement this logic yourself, or does the authentication have that role? Okay. So now that we've done that, we can update our spell expression. And our spell expression now needs to use authz. So that's the bean name. The bean name by default is the name of the class. Check, authentication, and then the return object. And so you can see what is this calling? It's calling that check method, right? So it actually auto-completes to that. And there's other tricks you can do. You can use the principal, and if the principal is your own domain object, you don't even have to have Spring Security in this object. You could say like, my bank account user could be the principal that's being passed into here, and then even this logic is decoupled from Spring Security as well. So we'll rerun our test real quick. And if we typed everything correctly, everything passes. All right? So the other thing that's nice about this is the spell expression is simple. Any authorization logic that you want can be tested independently of the spell expression, and you can do whatever you want. So if you need to delegate to some authorization service outside, say you're using like OPA or something like that, you can delegate to some external service to do all your authorization logic and still use Spring Security for method level support. And you can do the same thing for like the web-based support as well. That said, we're going to wrap it up here so we have a few minutes for questions. I'm not sure how we do that with the live stream too, so Dan, if you could...
Yeah, we can take one question really quick, and then
Okay.
we'll have to get Dennis up here. So one question. Anybody got a question for Rob? Whoa, that was just a lot of information. People are trying to consume it, I think, still.
We can do questions afterwards too. I'll be available right over here.
Yeah, and we also have the Discord channel, so if you're here or on the live stream, you can ask questions there, and we can see if we can answer them over there. So thanks, Rob.
All right, thank you everyone. I appreciate it.